Have you ever experienced sudden heavy rains, stormy wind and caught in waterlogged road? Well, if you are from coastal area, it is nothing new for you. You might have experienced cyclone, tsunami and flood. If you are not from coastal area, you have seen on your TV the live coverage of tsunami in Japan and India and also the cyclone Phylline. If you recall, many people lost their lives in the year 1999 Orissa cyclone, in 2004 tsunami and even in 2013 Uttarakhand cloudburst. Today we can think of zero casualty. But how is it possible? Yes, it is possible due to the advanced technologies that have come to our rescue. Just like the cyclone Phylline in Orissa, meteorologists have predicted almost 5 days in advance about the cyclone, and these 5 days have given us enough time to evacuate people from the cyclone's path. Just like the cyclone Phylline, wherein geoinformatics technology is used, there are some other areas of application of this technology. To discuss some of these applications in these technologies, we have Professor J.K. Garg and Dr. Venidhar Desmukh in our studio today. To my left is Professor J.K. Garg. He is currently Director, Center for Disaster Management Studies, Guru Govind Singh Indraprasth University, New Delhi. He has earlier worked at Indian Space Research Organization Center, Space Application Center, Ahmedabad. And to my right, Dr. Venidhar Desmukh. He is Associate Professor of Geology and School of Sciences, IGNOU. His area of specialization are geoinformatics application for coastal geomorphology and coastal environment. Well, let me ask the first question to you, Professor Garg. As you have worked for many years in Indian Space Research Organization, can you give a brief idea about what ISRO is doing in this kind of application, that is geoinformatics technology, and what are its thrust area?
ISRO had a very humble beginning, if I can say so, in 1963, when from Trivandrum, presently now what we call Vikram Sarabhai Space Center, we launched sounding rockets. Earlier ISRO was part of Department of Atomic Energy, and subsequently it was separated and constituted as Department of Space, and ISRO became its research wing. In 1972 ISRO was established, and in 1975 Space Application Center at Ahmedabad came up. Basically ISRO carries out research in many areas, and first and foremost being design and fabrication of satellites for communication, for remote sensing and for variety of other purposes like lunar missions, etc. Then to do that, to launch the satellites, launch vehicles with which you are familiar, normally you see in the TV, polar satellite launch vehicle is there, geostationary launch vehicle is there. These launch vehicles are prepared at Trivandrum. Then satellites are launched from Sriharikota in Nellore district of Andhra Pradesh, and applications are conceived mainly at Space Application Center, Ahmedabad, though operational applications are done at National Remote Sensing Center at Hyderabad. Now as far research is concerned, this is being done in all these areas besides applications in communication and remote sensing, plus developmental communication also. Now in communication we make satellites, payloads, transponders are there with which you are familiar. You watch television, satellite television is there. This technology was mastered at Space Application Center, and now it is integral part of our INSAT series of satellites, as you may be aware. This process started in 1983 if I recollect correctly. Then the first operational remote sensing satellite was launched in 1988, on March 17, 1988 to be precise, and then we have not looked back. And this is the main activity of geoinformatics which is being done at ISRO. We are launching satellites. Then we have developed software also at Ahmedabad. ISRO GIS is known to various people. You know, it is a software which combines remote sensing, image processing, as well as geographical information system applications. Then software is developed, then applications are conceived in diverse areas of geoinformatics like crop acreage forecasting, ecosystem inventory and management, coastal zone management, snow and avalanche studies, hydrology, coastal zone management including potential fishing zone, and so on and so forth. In fact, the applications are endless which are being done at ISRO and Ahmedabad.
Yeah. Well, there is a diverse range of applications as you have told about ISRO. I would like to ask about SAC. What was your area of interest and what other researches you carried out there in SAC?
Actually, SAC application started way back in 1974 and I joined Space Application Center in 1976. So prior to that, two experiments mainly pertaining to agriculture resources survey experiments were conducted, one for Anandpur in Andhra Pradesh and second for Patiala in Punjab district, basically for crop inventory. Then we had small beginning. It was a small center with about 300 people when I joined, and now we have more than 2500 people at Space Application Center, Ahmedabad. Regarding applications, we started with the crops and forestry, but now large number of applications are done in various spheres as I have earlier mentioned, especially in crop acreage and forecast, forestry, wetland conservation and management, coastal zone management, snow and avalanche studies, hydrology, potential fishing zone, and so on and so forth. But my main area of work was basically pertaining to environmental applications. The first of which was done in 1984. We started with environmental applications in ISRO, and the first was to assess using remote sensing. At that time there was no GIS, to use the technology for assessment of environmental impact of thermal power generation and mining activities on environment. This exercise was done for Kudremukh in Karnataka and Dehradun Mussoorie limestone belt for mining areas, and for Korba in Madhya Pradesh at that time and now Chhattisgarh, and Talcher in Odisha for studying the impact of thermal power generation on the environment. Then subsequently the first scientific inventory of wetlands in the country was conducted using satellite data of 92-93, and this experiment was completed in 1998. Besides this, work was done for landslide hazard zonation, impact of earthquake on the environment, and so on and so forth, besides forest fire hazard zonation also.
Okay, thank you sir. I will come back to you regarding environmental application, but coming to you Dr. Desmukh, I would like to know about that you have a vast experience of working in ISRO. So, what kind of work you were involved in this organization?
Okay. The Space Application Center, I was involved in some projects which were about the use of remote sensing and GIS technologies for specifically coastal applications, and it was about the coastal landforms, coastal ecosystems, coastal habitats, and so on.
Okay, as you have mentioned, you have worked there in coastal application. So, our viewers would like to know about the application of geoinformatics technology in coastal environment and even in coastal ecosystem.
Yeah, these technologies are particularly useful for coastal areas because the coastal zones are highly dynamic because of the continuous interaction of oceanic, atmospheric and terrestrial processes. The remote sensing provides synoptic coverage of hard to access terrains like coral reefs and mangroves. Besides, it is also a non-restrictive means of data collection for fragile and sensitive ecosystems. Now, if I talk about some of the common examples of applications of geoinformatics technologies in the coastal areas, it could be the delineation of coastal zones and their boundaries, shoreline mapping and monitoring, mapping topography, bathymetry, monitoring of coastal habitats and ecosystems, and also for monitoring impact of natural events such as cyclone, tsunami and flooding. Now, coming specifically about the coastal ecosystems, this remote sensing data can be used for mapping and monitoring coral reefs, identifying mangrove areas, mangrove habitats, and even for community zonation, and also for mapping seagrasses, macroalgae, and we can even use it for marine protected areas like for zonation and site prioritization. We can also use this technology for potential site selections for say aquaculture.
Okay, you have also an experience of working with DRDO. So, what you were involved in DRDO is similar to that of ISRO or something different?
Okay. At the DTRL, I was involved in problems which were about delineation of certain landforms like coastal, fluvial, desert, etc. At the CDAC, I was involved in some projects which were about deriving information about the land use, land cover, land degradation, and also about geology and geomorphology. And there was also one project which was about identifying potential mineral zones also.
Okay, as you have mentioned that you have worked there in the field of geology, geomorphology and even mineral exploration. So, our viewers would like to know how geoinformatics technology is used in the field of geology, geomorphology.
Okay, there are many application areas regarding geology and geomorphology. If I talk about geological applications, there are certain applications which are possible are lithological mapping, delineation of geological structures, identification of potential mineral zones, and also identification of potential groundwater zones. If I mention about geomorphic applications, the common application areas are about the topography, mapping and monitoring different kinds of landforms and the drainage networks, and also understanding erosional and depositional processes and identifying erosion prone areas.
Coming back to you, Professor Garg, I would like to ask you that you have completed many projects in the field of bioresources and environment. How this application of geoinformatics has an advantage regarding or comparing with the manual processes in especially in the field of environmental application?
Yeah, that is a very good question, and basically let me tell you, suppose we have to do inventory of wetlands or any ecosystem in the country, and if we use field based methods, then it may not be ever complete because the information will be difficult to come by, and even if you do it, then its size, its condition, etc. will be difficult to map. If you are doing on sample basis, it's fine, but if you are doing at country level or national level or regional level, then there is no other way except to use this technology of geoinformatics and to generate even information systems. Now, for example, in our country, we have information system pertaining to wetlands, pertaining to biodiversity and pertaining to other host of areas. Regarding environmental impact assessment, actually incidentally I am member of Quality Council of India, which accredits various agencies for environmental impact assessment. It is a prerequisite that they have to provide information about land use, land cover and other environmental conditions using satellite remote sensing. It is compulsory for them to provide what are the existing conditions and what are the likely conditions which may take place after this project is established or granted.
Okay. Here I would also like to bring to the contest about recently the geoinformatics technology is used in the disasters of Uttarakhand and Orissa. So, can you give our viewers an idea about how this technology is used in the study of natural hazards and disaster?
Actually, this technology is very useful in all spheres or all you can say cycles of disaster management involving relief measures, mitigation and other activities which are associated with disaster management. Now, to take the specific example of Odisha cyclone Phelan. Now, as you have mentioned in the beginning itself that prior to the landing of cyclone on the Odisha coast, we were knowing that when the cyclone is coming, what is its position, what is the speed. So this is regarding our you can say prediction of any activity. Similarly, for Uttarakhand also it was not possible to predict in advance, but still whatever impacts were there on the ecology and environment, still that is possible. But one thing which was missed in this, that there are many glacial lakes which were overflowing as far as newspaper reporting goes. So they could have been mapped using satellite data, perhaps that was not done. But in mitigation and relief measures, the technology has been used greatly.
Sir, how this technology is also used in the landslide studies? It is connected to the hazards and the disasters itself. So, can you tell something about the landslide zonation map?
Landslides are a recurring disaster in the hilly areas, especially the Himalayas. Every year a large number of people, sometimes if the tragedy is big, hundreds of people die. For example, in Malpa, if you recollect, that Protima Bedi and host of villages were washed away. Similarly, in Bhagirathi and Alaknanda Valley also there are many active landslides which create problems every year. Now, this geoinformatics technology, especially remote sensing, can be used very effectively to locate the existing landslides, to locate those landslides which are dormant, and to even identify some plant species which are indicators of landslides. Then based on this information and host of other parameters like geomorphology, structural geology, land use, road network, drainage network, and if we combine them in GIS and use some multi-criteria for zoning the area, then it can be very easily done in GIS and a landslide hazard map can be prepared without much effort. And this will not take time, and incidentally let me tell you at this point that for this Uttarakhand disaster, way back in 2004, Space Application Center has prepared landslide hazard zonation map for the entire valley. And prior to that, even National Remote Sensing Center has prepared landslide hazard map of the important religious routes.
Coming back to you, Dr. Desmukh, can you give a brief idea about some major initiative of government wherein these technologies are being used?
There are a number of parameters which are being generated and used in major government projects. To list some of them, Village Resource Center, which we call it as VRC, National Natural Resource Management System, Natural Resources Census, Pradhan Mantri Gram Sadak Yojana, and crop acreage and production estimation as mentioned by Professor Garg, and also potential fishing zones forecast. So these are some of the major government initiatives where this geoinformatics technologies provide very critical vital inputs.
Well, at the end, Professor Garg, the question arises, in spite of having all these technologies, we are unable to control these natural calamities.
Actually, if you see this recent Odisha cyclone, by the use of the technology we could save a large number of lives. If you remember, if you recollect this Odisha super cyclone, so about 10,000 people were dead because of that. And in 1978 also, if I recollect correctly, in another cyclone, thousands of people died, perished. At that time this technology was not available. Otherwise this damage, especially tracking the cyclone, was possible at that time also if we were using some other country's satellite. Then other disasters like flood. Now we can know well in advance that what is the incoming water from lakes, reservoirs, etc. in the Himalayan region, plus rainfall pattern. And based on that, we can plan our strategy so as to minimize loss of life. Infrastructure losses will be there, because in such calamities you cannot prevent that, but lives at least can be saved.
Okay, sir. Today, the learners must have got an idea about the application of geoinformatics technology in the field of geology, geomorphology and environment. There are a range of application of this technology in the field of natural hazard, demography, archaeology, business, health and many other areas. I would like to thank Professor Garg and Dr. Desmukh for sharing their experiences and giving their views and ideas on the application of geoinformatics technology. Hope we will meet again.